All right, hello. We're going to dive into a program that demonstrates how to represent a graph using an adjacency list. The graph is based on actors and their movie collaborations. I just thought that would be fun. Like the Kevin Bacon famous 6 degrees of separation. Okay, so let's break down the code step by step. We're going to start with the headers. I've included IOStream for input and output, so we can print the adjacency list. We have map, which helps us store the adjacency list where each actor maps to their connections. We have vector. This is used for dynamic arrays to store a list of connections for each actor. And string is going to enable us to work with actor names as strings. I'm also using the namespace std so I can simplify my code and avoid repeatedly typing std. All right, so the graph class definitions. We have the private member adjacency adj list. I apologize, adj list. And this is a map where the key is a string, in this case, an actor's name. The value is a vector string. And this containing their connections, other actors they've worked with. We have the public methods add edge function. It adds or updates the connections for a given actor. For example, Kevin Bacon connects to Tom Hanks, Jack Nicholson, and Matt Damon. And then we have the display graph function. It iterates through the adjacency list and prints each actor along with their connections in a readable format. Okay, so the main function, the building of the graph. Let's walk through the main function. We create the graph. Start by creating an instance of the graph class. Add connections. So for each actor, we're going to call add edge here to define their connections. For instance, Kevin Bacon connects to Tom Hanks, Jack Nicholson, and Matt Damon. Tom Hanks connects to Kevin Bacon and Meryl Streep, and so on. Okay, then we have the display, the adjacency list. Down here with the display graph. And this is to print the adjacency list. This shows each actor and their connections in a clear format. And then, of course, end program by returning 0. So let's run this. All right, when you run the program, here's what you're going to see. The adjacency list for the graph, and then each of their connections. So Jack Nicholson connects to Kevin Bacon, Kevin and Matt Damon. I apologize. Julia Roberts connects to Meryl Streep and Matt Damon. Kevin Bacon connects to Tom Hanks, Jack Nicholson, and Matt Damon. Matt Damon connects to Kevin Bacon, Jack Nicholson, and Julia Roberts. Meryl Streep, Tom Hanks, Julia Roberts, Tom Hanks, Kevin Bacon, Meryl Streep, and so on. So why is this useful? The program illustrates how graphs can be represented can represent real-world networks like TV collaborations in this case. And the adjacency list format is efficient, especially when the graph has many vertices but relatively few edges. It's a practical way to work out with networks in fields like social media, logistics, and you guessed it, movie trivia. All right, so give it a try by adding more actors and connections and see how the graph grows, or don't. But thank you for coming, and I will see you in the next one.